So now we're going to discuss what happens if we have a time shift in our signal or function. So taking the same signal f of t from the previous video, we have 3 sine of t. We're going to make g of t, our modified function, shifted, say, 3 units to the right. So we have f of t minus 3, which equals 3 times sine of t minus 3. I've imported an image which shows you this new g of t function. So we're graphing g of t by t. So this is 3 sine of t minus 3. And we're going to calculate the energy of this new g of t signal and compare it to the energy of our original f of t signal and see what the change is, if there is any change. So conceptually thinking about this, if we shift the signal around by any amount, is it really going to change the amount of energy that we have? So let's calculate the energy of g of t to find out. We have the energy of g of t is the integral from 0 to 2 pi, it still exists from 0 to 2 pi, of 3 sine of t minus 3 dt, and that entire inside of our integral is squared. Then that becomes the integral from 0 to 2 pi of, well, we have 9 times the integral from 0 to 2 pi of sine squared t minus 3 with respect to t. And from the last video, we integrated sine squared of t a lot. Now, skipping over all the math and just getting to the core of the lesson here, this integral becomes 9 times 1/4 times the quantity 2t plus sine of 6 minus 2t minus 6 from 0 to 2 pi. And simplifying this further, we have 9/4 times 4 pi plus sine of 6 minus 4 pi minus 6 minus the quantity of sine of 6 minus 6. This is equal to, well, let's see what we can simplify here. We have a minus and a minus, which goes to a plus, so that cancels with our negative 6. And then we have, so then we're left with 9/4 by 4 pi plus sine of 6 minus 4 pi minus sine of 6. And this is equal to, well, sine of 6 minus 4 pi is equal to sine of 6. So these will cancel out, and all we're left with is 9/4 times 4 pi. And our 4's will cancel, which means all we're left with is 9 pi. So the energy of our shifted f of t signal, g of t, is the same as our original signal, f of t. So a time shift does not change the energy of the signal. And this is true for any signal, not just the example that I'm using in this video. If you shift a function or a signal by any amount, it doesn't matter the amount, you're still going to be taking the integral of that signal over certain bounds, and you're going to wind up with the same exact number. Again, if you want to download the notes that I've taken in this video, it will be down in the description below.